All right. Okay, so let's talk about JPA. So JPA is one of several object relational mapping solutions for the Java programming language. And as a demonstration of using JPA, we're going to be building an application that will allow us to represent course material, right? Where you might have faculty being able to author courses. Courses can contain multiple sections, and you can have multiple students that can be enrolled in these sections. Okay, and so we're going to be using JPA to be able to interact with the database. So first of all, we're going to just set up the environment real quick. We have here STS, or Spring Tool Suite, and here we're going to just initialize the project as a starter project, the Spring Boot starter project, and we're going to call it course management, or course manager, and this will be just a lecture. Okay, so let's go next. We're going to add a couple of dependencies: JPA, web, and a embedded database for now. And we're going to say finish, and this will create the default project. Okay. All right. Also, we're going to be creating a database where we can interact and store our data. So let's go to MySQL, and we'll create here a database, and we'll call it course manager lecture. We'll say apply. Okay, we've created it. And now we'd like to be able to connect to this database using JPA. All right, so to do that, we're first going to configure the communication with the database. Instead of us deliberately getting a connection using the JDBC driver, instead we're going to delegate that task to the framework, to the infrastructure. Instead of us getting a hold of a connection, using that connection, and then throwing it away, right? Instead, we're going to tell the server, "Hey, server, when you boot up, hey, maybe create a couple connections for me, and then I can ask you for those connections." Right? This is a much better use of resources, right? Because connections in general are very expensive objects to instantiate. Right? So just throwing them away, it's after you have expended effort in instantiating and connecting to a database. It's a very bad use of resources. Instead, what we're going to say is that instead of getting a performance hit every time we need to connect to a database, we'll take that performance hit just once, right? When the server boots up, right, the server will go and make connections to a database, and then just make them available in what typically is referred to as a connection pool, right? Servers can be configured to, at boot time, open up 10, 20 connections to a database that are ready to go, right? And they're available to any thread that might want to ask for it. Okay, so that if a thread needs to get a hold of a database connection, it doesn't have to itself create the connection from brand new. Instead, can go to the infrastructure and say, "Hey, give me a connection that's free. It's taken from the pool is marked as busy, right? That someone's using that connection." It makes a connection to a database, and then it releases it, right? It does not destroy it. It's moved back into the pool, right? And you can do all sorts of optimization when you use this schema, right? What you could do is that, for instance, depending on the load of the server, right? Depending on how the server load changes over the day, right? You can configure your server to I need more connections, right? So you can put a growth factor. You can say, well, if you run out of connections, right, or if you're about to run out of connections, well, create another 5, right? And so the pool of connections can grow throughout the day, right? And then it can throttle back down, so that during the evening hours, or when people are starting to have less activity, right? The connection pool can shrink, right, and just release the connections as it doesn't need them anymore. Make sense? That allows the footprint of the server to adapt to the load of the application. So to do this, because we're not going to configure this internally in the code, we have to configure it somewhere. Okay, somewhere it needs to be configured, and we're going to be configuring here in application.properties. Right, that's a very common place to configure server-wide, infrastructure-wide properties that you can turn on and off. Right. Another advantage of this is that when we were using the single connection, if you remember the connection strings, as much as we were saying that our JDBC is independent of vendor, right? We still had to hardcode as part of the URL. We still had to hardcode JDBC : MySQL in there, right? So our code was not entirely independent of the vendor, right? If ever wanted to change the database vendor, I actually had to go in the code and change that connection string. Also, the driver also was hard-coded in there as well, right? Again, another weak point there that we need to change the URL, the class name for the driver that we wanted to use. Anyway, that could have been configured outside as a properties file, and we could have read it dynamically, but this is a much better solution. Okay, to have it inside of an application property. So here I have a boilerplate configuration, which I'm going to copy, and I'm going to paste it inside of our resources file. There it is, my application properties. By default, it's empty, so I'm going to paste that in there. There we go. So my machine is the local machine that is running on, so it's localhost or 127.0.0.1 or whatever you prefer. Or if this is being hosted somewhere else on AWS or whatnot, it will be the IP address of where that's running. So here will be localhost. The database that we're using is Course Manager Lecture, I believe. For a username, I believe it's root, and the password is the password. Okay. All right. So that's a data source configuration. The other couple of configurations here are JPA and Hibernate specific, right? We can talk about it. Here the update. Here you can configure how do you want JPA to interact with the schema. How do you want JPA to create the schema? Because we're not going to have to create any schema. Okay, we're only going to have to create a Java objects or Java classes, right? And those Java classes are going to be automatically converted into MySQL schema. Okay, so if you have a class called course, there will be automatically there will be a course table created for us, right? And depending on the fields of that course class, there will be equivalent fields fields created in the schema for us automatically, right? So updates, there's several options here. It could be a create, there could be an update, right? So create means every time it gets the server runs, every time JPA gets instantiated, just throw away any schema that were there before, right? And just create a brand new schema for this. That means that any records that you would have had there would have been removed, right? It would drop the old schema, right? And it would create a brand new one, right? Every time. Whereas update, it'll make a best effort to update the schema so that any fields that haven't changed will still be there, right? But if you add a new field or a new record, or I'm sorry, a new property, or you remove a property, it'll just do alterations to the original schema that it created. Okay. Another option that is interesting here is that at runtime, when we're using JPA and we're sending commands to add data to a database or retrieve, what we're going to be able to see in the logs, we're going to be able to see the actual SQL that it's using, right, to interact with the database. Because internally, down underneath, it actually uses JDBC underneath, right? The thing is that we're not going to have to do that ourselves. Instead, it's going to be JPA. JPA will give us a much higher level of abstraction to interact with the database. Okay, so we can, it'll be very interesting to look at the actual SQL that is being used to interact with the database. Now, in production, typically you would turn this off, because there's no need to just litter the log with all this information. But for development purposes, this is a very good option to turn on. Right? You can actually see the SQL. You can copy the SQL, right, and just paste it on the database to see if there's something wrong, right? Because oftentimes, there'll be cases where it's doing some weird things, right, that you don't understand, and it's a very good idea to look at the SQL and try it out yourself. Copy the SQL that it's using and paste it in the database and see if it's what you expect it to behave. Okay. Here, there's a couple of strategies that you can turn on what the naming strategy that you want to use. So, for instance, in Java, typically you follow a particular naming convention, right? Typically it's all camel cased, right? The first letter of a variable is lowercase, and then every single word that starts is uppercase, right? The naming convention typically in relational databases is to use underscores instead, right? Between the words, right? And you can configure how your naming convention you want it to be, right? Right, if you want to use underscores, you want to do camel case or all lowercase or all uppercase or however you want it. And here is this is the strategy that is chosen here. Another configuration here is a hint at Hibernate to say, well, what database are you talking to, right? Each vendor has a slightly different dialect of SQL. Okay, so depending on the database vendor, you might want to use the optimized dialect that for that particular vendor, right? And so in this case, we're optimized to use MySQL dialect, right? So that the SQL that is going to be generated is going to be specific for the for that vendor. Notice here that we have the URL. Notice that it's no longer as part of the source code, right? Instead, it's being configured here as a properties file. Okay. Everybody good? All right, awesome. All right, and here's the data model that we're going to be using. We're going to be implementing a couple of various ideas on the data modeling, right? So, for instance, here we have inheritance. We have faculty and student inheriting from user. We have a couple of one-to-many relationships between faculty and courses, or faculty and sections. Then you have a many between students and sections with an enrollment association class in the middle. Right, so this will give us a chance to explore several of the ideas that we mentioned earlier, some of the challenges on implementing some of these, mapping this data model, right, to this hierarchical object-oriented data model to a flat SQL relational database. Okay, and we'll do that next.